Okay, so I'm just going to walk you through the process to download the data. I know a lot of you have already been doing that already, but let's do it now anyway. So go to census.gov. And this is all for the ACS data. Go to American Fact Finder, and for now, stay with the older version. And again, you only want to really download from the download center. And then choose 2005 to 2009 American Community Survey 5-year estimates. And then within this, where you begin to choose the geographic summary level, you want the smallest division possible. And for the estimates, the smallest division is the census tracts. And then select the state. I'm just going to do New York for now, but you guys' map might also include New Jersey. And you can only choose one county at a time. So I'll choose the Bronx. And then hit go. Okay, and then within this is where all of the data is stored. So you more or less need to just scroll through here and decide which pieces of data are most helpful to you. If you go to a specific piece of data and you click on what's this, then you can see how they've actually organized within here. So in this case, it's just the median age, and they'll show it each for male and for female. You have to take note that, like, a lot of times you don't want to get too specific when it comes to like choosing something. Try to pick the most general version of like age or sex or race, because within that there's already like numerous subdivisions. And so if you want to reduce the amount of times you have to come back to this website and download, that's the best way to do it. So even for race, you have, these are the different subdivisions within there. For now, I had a list for you guys, what some of the numbers are for some of the things I think you're going to want. So I can send that to you, just so that you don't have to click around quite as much. But I'm just going to do, for the purposes of this tutorial, the population, the race, and the ethnicity. So I'm specifically just going to extract the percent that is white, the percent that is non-white, the percent that is black, and the percent is Latino or Hispanic. So we want first to grab the total population, which is at B01003, and that one's pretty obvious actually. So the beginning of this is going to be kind of tedious to watch because this whole task is actually incredibly tedious. Then you're going to want race, which is B02001. And then ethnicity, which is B03002, I think. And then, other things you might want are like the median household income, household type by household size, occupancy status. That will tell you whether or not the houses are vacant or occupied. Yeah, I mean, if you go through here, there's like a number of different things you guys are going to want. It's like not printing half of my notes. Okay, so then you go to Start Download. And it downloads a zip file. If you go back, so you want this for numerous different counties, but so if you do it all at once, if you go back to the geography and you go again to census tracts, New York, and then go to Kings County, then you already have these added in this lower section. So you want to do this all at once, just because I recommend that you guys decide which pieces of data you want to download, like all of them at first, and you download them into one large zip file. Because when you start to make the calculations in Excel, then you can do them all at once. It means that whoever is in charge of that task has to, there might be a few of you, but it will take longer, but it will actually, at once, but it will actually reduce the amount of time you actually have to do this. So you have to do this for every county. So I'm just doing the 5 counties that the boroughs are in. But again, you'll have to do New Jersey as well. Okay, so now that we have those, where do they download to?
They'll go to downloads, which is below unfavorites, the second one. Inside everything.
I'm just going to open it. Okay. So then you just unzip these folders and
you say close.
So if you open up the text file, the README one, you can see which county this is. Oh, let's see. I did this on a Mac, so I have to readjust. So basically all you're downloading is a series of text files that are pipe delineated, so instead of commas, which you'll see, these are pipes. Do you guys see where it says the county?
It's Kings.
Kings, okay. So just like make a new folder for each of these.
I think if you right click on the archive, it'll say extract to folder.
Oh, okay.
Yeah, extract to. If you like right click extract to, it'll make a folder right here.
Okay. Okay, so the first one was the Bronx. The last one was Queens. And I don't remember how I did this. Thank you. So again, make sure that none of your folders have spaces in them. Okay, so the Excel portion is going to be a little slow, sorry. So then we open up Excel, and you go to, let's see. Insert. I'm not used to working with this version. You just, on any other computer, you just want to go to File, Insert, so wherever that might be.
That's a good question. I've never used this either.
You're importing.
Yeah, you just want to import. Like,
Oh, maybe this little button up there.
Google data, maybe the data tab.
no, that's not it. I just tried that. Why did they make the interface worse? Okay.
Maybe go back to home. Oh.
Okay, maybe this will work. So, data from text. I'm not sure what version of Excel is on your computers in Studio, but it might be the same one. If you're using a Mac, you just go to File, Import. So you want to grab the data file, which is a text file, and it says so right there, and you want to import it. And when you do that, this window shows up, and you want to click on delimited, and that means that it's delimited with either commas or pipes, or that each of the pieces of data that would generally have its own cell has some sort of character to delimit it. And then go to next. And in this case, you want to go to other and just type in the pipe, which is above the return key. And you can see already that it kind of organizes it here. That's all you need to do, actually. And then insert it there, and then here it is.
The actual symbol that delimits
Yeah,
the data.
you want to make sure that whatever it's delimiting is actually the kind of file that you download. So generally when you download it, it will tell you it's either a comma delimited file, pipe delimited file. And so you need to do this for every county. So you just scroll down. And click on the next cell and do the same thing again. So delimited, next, and then type in the pipe, and finish. So when you do that, it will also bring in the headings, so just delete those by selecting them, and then right-clicking and deleting. And this you'll have to do this over and over again. So if the more counties you have, the more times you actually have to do this. You can understand why this starts to get tedious. Oops. And Excel generally doesn't remember what you did last, so you just have to do it the same way every single time. I don't, like, most of us already know Excel, so I'm just going to show you how to do this, because some of the things, some of the tricks, like to fit some of these equations later, are pretty straightforward, but sometimes you just don't know them.
You go both tab and...
Yeah, I don't think it matters. Also, if you're downloading a ton of data at once, most likely it will give you more than one text file. It'll give you like data 1, data 2, data 3, and so each piece of data will look exactly like the ones that we're importing now, but you really still want them in one spreadsheet. So I recommend to do this procedure for every single one of them, so that they have their own Excel sheet for each text file, like data 1 and data 2, and then you compile them for each county. And then once you've compiled, for instance, like data 2, just import everything after these first. Just import the data and not the, just copy and paste everything after geo name. And then you would paste it at the end here to make it like a super long table. Does that make sense? And make sure when you do that you're importing, if you're doing the two data tables, that you're importing the counties in the same exact order. Okay. So once you've done that, you basically just need to go through here and clean up all this data. I mean, you can see it's pretty... Some of these, all they really need is a new heading. So in this case, you don't... by the end of this, you won't need this second row. You have to delete that. But it's helpful for now just to know like what each of these columns represent. So this one is population. So just go ahead and change the headings, like clean it up. I would even delete with whatever's in there. And then you're going to have these columns that have MOE at the end, and that's just to represent the margin of error, because these are actually averages. You won't get this when you download census data, like the 2000 or 2010 census data, but because these are averages, you have that. You can see, like in this case, the margin of error is plus or minus 407. I think for the purposes of this data collection, you won't need to use these, but it's just good to know that that exists. So you're going to be deleting anything that represents a margin of error. If you have a really large spreadsheet, I don't recommend going through and deleting the margin of error columns first. I would just do it as you move along, as you clean up the data. So again, a lot of times each piece of data will have its own total population associated with it. It's all the same. So in this case, this is the actual first piece of data associated with the race file that we downloaded. So you can just delete that one as well. And again, the margin of error is. So now we have this one that actually just represents white alone. So you can just retitle that, make it smaller, delete the margin of error. This one is just black alone. Delete the margin of error. And then you have all these other ones: American Indian, Alaska, Native American, Asian alone. So you guys can decide if you want to represent these graphically as their own entities. For now, I'm just going to I'm just going to find white, non-white, and black. And so that means I could either add all of these together, or I can just non-white by subtracting white from the total population, which is what I'm going to do. And so for now, I'm just going to delete all these other ones. And non-white includes multiple races as well. So yeah, make sure that there are no spaces in any of your title headings. And then just perform the calculation by using the equal sign and then selecting on the population, total population, and subtracting the white population and hitting enter. And you want to do this for the entire column, so, which you could do if you just drag this down, or you can just copy one of the cells and then select all of the other cells in the column, and then right click, go to paste special, and just paste the formula. And so now you have the non-white population. Because again, we don't really care like the total population that is white or black or non-white. We really only want to normalize everything by the total population. So we need really to find the percent white, percent black, and the percent non-white. And so we'll do that again with the same technique. So we're insert a column, we'll do percent white, and we'll divide the population that is white with a division sign. Oops. That's the division sign. And the total population. So now we have the percent. And so again, do the same thing. You get these errors when there are zeros, so we'll have to fix that later. So you're going to be doing this over and over again. Okay, I'll just do one more. And percent non-white. So in this case, because this one is actually already a formula, it's probably best to remove the formulas as you no longer need them. So just copy this entire column, and then paste special, and this time just paste the values. And this will just remove the formula. And so then you can perform the calculation. Okay, so I'm not going to do the rest of these, but you get the point. Some of the things that you need to pay attention to while you continue to do this for all the pieces of data that you download is that you don't always want to download, or you don't always want to delete by the total population. For instance, when you download the means of transportation to work, when you want to find the percent that use public transportation, you only want to normalize by the population that actually commutes, So you would take the total population and you would subtract the people that work from home, and then you would use that to normalize. So you have to pay attention to these because that happens for a number of other data variables. And so just make sure that whatever you're normalizing with is actually what you think is the most correct piece of data.
Is there an advantage to normalizing in Excel as opposed to normalizing in the map?
Yeah. Oh, I see. It is because you have to do it so many times that Excel is a better place to do any kind of formula calculation. If you can reduce the amount of actual calculating that you have GIS do, it's better just because it can become corrupt so quickly. I don't have any other reason other than that. It's also a little bit like the interface is slightly easier, and maybe even considerably more easy. So another thing to pay attention to. So when you go to delete or when you go to export this data, so that you can open it in Excel, you can't have any formulas at all. So I would recommend like performing all of the calculations and then cleaning everything up and then saving as a new file and then just like copying everything and then pasting it again as a value. And this will just remove all the formulas. And you can't have any of these division errors. And so you have to do a find, and you have to find each of these, which is super easy. And then you want to replace it with a blank. So don't even type anything in. So find all and replace all. For some reason it put plus mark or apostrophe or exclamation point in.
It was there.
Yeah.
It was there?
Yeah. It was. So just do find exclamation
Oh.
point. It was fine.
Got it. How did that happen? Okay, so that's pretty straightforward. And what you want to do is, you don't want any of this, obviously. I'm assuming that you would go through and you would clean it all up. I'm not going to do that now. So I'm just deleting this. And then, in order to open it in Excel, you also need to delete this. You can only have one heading. And then you need to save as the standard format when you save an Excel file is XL. It's like XS. Let's see what it is actually.
XLS.
But it adds another X at the end. So you need to make sure that it doesn't. So there's not, it
If you
doesn't,
right click and go to properties.
I think the X is still there.
it is there. So yeah, that's just, it still doesn't tell you. Well, anyway, just know that there's another X at the end, and you can't open that in GIS, so you just need to save it.
It's an Excel 97 to 2003.
Yeah, exactly. Save it down. And Windows XP, that's on the computers at school, you can see all of the file types. Okay, so then once you do that, you have all of this data, but you also need to download the boundary files. So if you Google census boundary file, really. Okay, so the first thing that shows up when you Google boundary file is the census.gov website. And so in here, we downloaded census tracts, so we need the boundary files for census tracts. You just need to know that because the data is associated with a certain geography, you need to have the shapefile so that it can actually map it to that. So census tract. And it gives you 3 different types to download, and this is a .e00. You want to make sure to download the shapefile and download it for New York and or New Jersey. You also want to download the county file, and you'll use that to perform your clips. So county subdivision, and again the shapefile for New York. Okay. And then that's one of them. I'm opening Rhino now. Sorry. Okay, so this is the census. This is the county file. And this is the tract file. So you want to import, like we did last week, those files into ArcMap. So go to the plus sign. And add the shapefile. When you do that, you'll see it says the following data sources you added are missing spatial reference information. So this is what we talked about last week in terms of the coordinate system and also the projection. So when you import it, you see that the state of New York looks really strange because we haven't assigned it to any geographic coordinate system and because it's projected in the wrong projection. So let's delete it and then open Arc Catalog. And then we want to refresh so that those new folders will appear. And then so go to the right click and go to the properties of each of the shapefiles, and you see there's nothing associated here. In our catalog, we want to assign the coordinate system. And that's what we do in the properties of the shapefile, and then we'll project the files in ArcMap in the viewport. So the coordinate system, if you go to the predefined coordinate system, we want, again, to go to the geographic coordinate system, not the projected, and then go to world. And the census data is projected to WGS 1984. So assign that, and you need to do it for both of the shapefiles that you downloaded. So properties, coordinate system, predefined coordinate system, geographic, world, WGS 1984. Okay, and now you can import them. And it still looks funny because we haven't projected the map. Okay. If you right-click on the viewport, we did this last week, but go to data frame properties, and then the coordinate systems tab. This is where we want to project. So go to predefined and go to projected coordinate systems. And this is where you want to choose a coordinate system that is closest to the actual geography of the map that you're viewing. So in this case, I'm going to do a continental in North America. And then I mentioned this last week, but if we use Lambert conformal conic, it will conserve angle. You'll see there are other ones. This one conserves area, and we'll talk about that later. And actually, this one might even be better, the USA contiguous Lambert conformal conic, because it's even closer to the geography. So apply, you'll get this window that tells you that the geographic coordinate system is different than the projected, but that's fine. And then right-click on the layer and then zoom to the layer. So you see, now it looks a little bit closer to what we can recognize. So once you do that, we need to import the Excel file. But first, we don't need the entire state of New York, so let's make a clip. If we zoom into I'm not sure why we can't see me.
You got to turn it on.
Oh, thanks. So if we zoom into New York, you guys will have New Jersey as well, but use the selection tool, which is here, and just select the counties that we actually want. And so in order to add to the selection, we need to change the interactive selection method to add to current selection. And so these are the 5 counties. Right-click on the layer, the shapefile, and export the data. Say yes, and now we can delete this layer, and we can use this one to clip the census tracts for those counties. So in order to perform a clip, you need to just type in clip into the search engine. It's in the ARC toolbox in the favorites, but it's actually faster to just find it this way. Double click on the Analyze tool. The input features are the tracks. The clip features are the counties. And then we want to save this shapefile as well.
Is there a way to clip? Is there a way to export data from multiple layers into one
Let's see.
thing to clip from?
No, I think you can only do one at a time. I think it's because because this takes the data, clips it, and then assigns it to a new shapefile. You can't put multiple pieces of data in one shapefile, I'm assuming. Okay, now we just want to delete this. Okay. So now we have the census tracts for the 5 boroughs. And we need to add the Excel sheet. So we can do this the same way that we add shapefiles, just add data. and we can see the XLS file that we saved. And when you do that, it brings a new window, and it references the different sheets that you might have in each file. And so you just want to bring in the sheet that you were working on. And it immediately puts your XLS files are read-only in ArcGIS, so you can't actually edit them in the data table. And they also only appear in the source tab. So you'll notice that this looks slightly different than what we're used to seeing here. But you can open this now, and you can see that everything is imported correctly. Wherever there was just a space, it says null, but those are fine. You want now, in order to be able to map this data, you have to produce a join to the census tract shapefile. And so this is actually kind of complicated, because depending on the data that you're importing, you have to figure out what are the best sets of data to join. So basically you need to have, the join means that you need to have a column in this data set that also is represented in the attribute table of the shapefile of the geography. And so in many cases you actually have to produce that field yourself. But because we can't actually edit this XLS file, we want to export the data as a DBF and then import it again. So you're saving this and then you say, yes, you would like it to add to the current map. And now you can delete this XLS file, and you can open this database. If you notice, so it's kind of unfortunate you can't open two attribute tables at once, but if you notice these numbers here, you can kind of get a sense of what they actually mean. So it says 3605000100100, but if we open up the census tract file, we can see that 36 represents the state, 005 represents the county, which changes for the different counties. And then the next 6 digits actually represents the tract. And so we want to create this 11-digit number in each of the folders that represents the specific tracks for each of the data. And so you have to create that field. It took me quite a while to figure out the best way to do this, so you might really want to take notes on this, because you'll have to do this for sure. You want to add a new field, and you can name it whatever you want, but I'm going to name this join, and I'm going to make it a text field. If you right-click on the entire field and go to Field Calculator, say yes. We did this before, but so now you can see that there are different functions that you can perform on the data. So you have number, string, and date. So we know we want, in order to find this number, we want to add state to county to tract name, but we know that some of the tract names only have 4 digits, but some have 6, and we need it to be a uniform set of numbers across the entire field. And we're also not just adding the numbers, because we don't want to add 36 plus 5. We want to actually treat them as text. So in order to do that, we click on state, double click on it, and it will add it to the table below. And instead of using a plus sign, we use an and that will append the data to the next set. So go state, county, And then we want to add the tract, but we don't want to just add the tract. We actually want to add, you have to think about this. You want all of the 4-digit numbers to actually be 6-digit numbers. And so the best way to do that would be to add 2 zeros to the end of all of those cells. But you can't just assign them it doesn't know to only add the zeros to the 4 digits. So what you need to do is add 2 zeros to the end of all of these, including the ones that are 6 digits. And then you need to tell it to only keep the leftmost 6 digits. And so you can do this by, if you go to the string, there's a few different formulas that are really helpful. In this case, this one that says left with 2, let's see, whoops. You don't need to double click on that one, I guess. So use left and then tract. But we don't want to just take the last 6 digits of the first 6 digits of the tract. We want it to be tract and 2 zeros. And then if you do a comma, then you tell it how many digits to actually keep. So this is where you would put 6 in. And so now we're appending state to county to the first 6 digits of tract. And then press OK. And so now you have this join field. And now you need to make sure you have the same field in the, in this version you can open 2 at once. It is almost this set of data, it's almost the same thing. But if you notice, for some of these census tracts, there's like 27.02. And for some reason, in the GeoID2, it doesn't represent the 2 here, but it represents it here. So in this case, we just need to create a join field that is taking the rightmost 11 digits of the GeoID. So again, just add a field. Right click for the field calculator. And then use the right function and GeoID, comma 11. Okay. So those should be the same. Let's just make sure for the ones that have, so that has a 2 at the end. Okay, so now when you map it, you want to right click on the census tracts and there's this option called joins and relates, and you want to create a join. And you choose the field that you want to join in both cases, and then we want to join it to NYC race, which is the data table, and we also want to join it to join. Just say yes. It's going to. I'm not sure what that's doing actually. So now when you open up the attribute table, it also has all the ACS.
Yeah.
Exactly. It's more or less telling. All it's doing is telling GIS to link anything that has the same data in this join field in both cases, to append like all of the data into one row. So that means that now when you go into the properties, you can actually show like the % white for those census tracts. So another thing is you also want to calculate, you probably want population density. And in order to calculate population density, you have to calculate the area. And you have to do that again in the attribute table. So you need to create a field where GIS can actually determine what the area of each of these polygons is. But in order to do that, we need to be in a projection that conserves area. So just for the sake of this calculation, you have to change the projection to anything that, it doesn't matter as long as it conserves area. So I'm going to choose USA contiguous Albers equal area conic. And then when you open the, create a new field. Just, you can title it however you want. I think there might actually be an area field already associated with this data, but it's not the right area. I'm choosing double, just it's essentially just twice as much as the float. This is telling you how many characters it can recognize, and that it's a number. Okay, so it added it here. And then you right click and you go to calculate geometry. And you wanted to calculate area under this coordinate system and square miles. And then you want to create another field for population density. I'm making it a double again. So it says it's too long. And then just calculate the density by choosing the total population divided by the area. Okay, so now we want to make sure to go back to the right projection. So US contiguous Lambert conformal conic. You can see it changes slightly. And then now we can map population density. Okay. Do you guys have any questions? Okay. This is actually going to be pretty short, so I'm almost done. One thing, while you already produced all of your geography maps, so you have like all of the water and all of the roads and stuff like that for all of the counties? Mm-hmm. Okay, so you don't need to know how to find more of that data. So I want to show you an example of what happens when you try to add data to this that has a different geography or projection associated with it. So I downloaded from the NYC data mine the location of the ferries, the ferry terminals. So when we go to add that data, the shapefile, you'll see that it has its geographic coordinate system, which is what we assign in our catalog, is NAD83, which means if we were to just apply it, it would not line up with the map that we have already. So in order to make this work, you click on transformations, and then there's again this syntax where it's more or less a sentence: convert NAD83 to, and we know that we have WGS 1984, and then press OK, close, and there they are. It's showing these ones in New Jersey. And also, you guys probably already know this, but you can change the symbols in the same way that you can change the symbology for polygons. And you can actually come in here and edit it quite a bit. And then what else? I think this is all I was going to show you today. And then if there were any questions that you guys had when you were mapping.
2 questions.
Yeah.
What look like census tracts, and maybe they are census tracts, but they actually seem like they're part of the river.
Yeah.
What are those? And
Those
how do
are,
we build them?
yeah.
If we wanted to.
Yeah. So we kind of talked about this last week, but sorry. Yeah, that's just the way that they produce a geography for the census tract. So that is, in fact, the census tract. The only way to really get rid of that is to, well, the easiest way to get rid of that is to just add the water file and place it on top. And then just change the water so that it matches the background more or less. And then it represents the geography a little more accurately. Is that fine?
Yeah.
Okay.
The second question is, can we get Google Map data and import it into GIS?
Yeah.
Or do you have to filter it like Excel or use it?
I think how do you do it? You can export from Google Maps.
What's the problem for GIS, right? The KML converter?
It's the KML will,
It's the
it's output. So there is a way to do it. So if you were to create your own map, I'm just going to try to remember how to do this. And then let's say you have a series of, I've done this once before, of points, and you want to locate those in GIS. I think there's a trick. Let me just see if this works. Yeah, if you right click on the View and Google Earth tab, or link, and go to Save Link As, you can save it as a KML file, which means it's associating that point data with its actual geography. And then I wonder if we can just open a KML. Let's see. It's not it.
That's
Let's
it.
not do that.
Yeah.
It's that plugin right there. I think that they make
Which plugin?
Can you, when you're in Google, can you just,
Oh, in Google?
yeah, just try to, not in the map, sorry, just Google like a KML plugin for GIS or KML plugin as we.
There's a script in the.
Actually,
But
I think,
rather-
I think that the school computers have it. I'm not sure.
Yeah, I've done it before, but I used like this free mapping software called Cartographica, and it imports KML files like really easily. So, let's see. If you were in on your school computers, if it is in fact on the computer, if you were to type in KML into the search, it would show up as. See, these are all exporting.
Yeah.
I do think that the school computers have a way to import a KML.
When you right click in Google Earth,
Yeah,
or in the map,
yeah.
did it say anything else besides, like if you were to go save link as, is there anything else under KML? Like can you
Yeah,
save
yeah,
as
yeah.
anything else? No.
No. Let's see.
I did this last semester
Yeah.
for the housing student. Data mining, I know I did this.
I've done it too. I can't
And
remember.
It was like something about the address bar, where like then put something, but then change the last couple of letters.
Oh yeah,
Right? Like there's something like
I
that.
did that once too.
Yeah, like change the last couple of letters in it, and then it would download.
Right.
Then you'd be able to download it directly to your computer.
But it was the KML file. But no, I think it's the same. It's the same thing as like right clicking and saving it as.
Yeah.
But I've done what you're talking about as well. You mean like in that right here? You just change like the address.
Yeah.
It's just we have to figure out. There's a way to do it. I just don't know off the top of my head. And maybe it is a plugin, and maybe the school computers have it.
It's just a matter of
Yeah.
What's that?
it just seems like it's a matter of
Googling it.
using instructions.
Yeah, exactly. But that's how you save the KML. It's really easy, actually. Whenever.
You might not be able, this is kind of a more general question, you might not be able to show us either, but I think some of us are kind of grappling with the way, like how to use data to find sites.
Yeah.
Could you talk, I know that you used a bunch to find your sites for last semester. Could you talk a little bit about the way in which you picked a site using GIS data?
Yeah. Last semester I didn't actually use GIS data to choose my site. I used like the kind of research that you guys are doing now to determine like the history of a certain place. But we've done it before with like the Buell work, and the difference between what we're doing here and what we did in the Buell project is that it was more systematic there, where we already knew what was the set of criteria that would produce like the best sites for places that were in need of housing, and so we then weighted each of those criteria. So, for instance, we might have said that population density was given like a factor of 3. Well, like percent of black was maybe given a percentage of like 2.5 or 4, and then we actually kind of scripted that in our GIS so that it gave us like along one. We determined a certain transect from one point to another, and running along certain public transportation, and then based on that geography, we were able to determine like these weighted variables were like hottest in certain spots. That was how we did that. But I think Kazis agrees for you guys that it's not about being able to determine like the number one most perfect the like location for any of your factories. I mean, I think when you're looking at this data, like when you look at the ACS data and you see the demographic data, what are your initial reactions to what would be the most helpful for choosing your sites? Because you have to have some idea what your factory is, but at the same time you know that you want it to be some kind of like, you want it to be an incubator of some sort. So there are like the general criteria for like maybe even like poverty status, people that might need work. In terms of mapping that data, I think like maybe the easiest way to do it is to instead of doing like an entire range of values, like this is population density, if this was like the percent that was white, instead of mapping the entire range from like 0 to 100, you have to determine, like, just based on your own intuition or the research you've been doing, you only want to map like where there is, you know, from like 0, you give it like a threshold from like 0 to 30. I want to know the areas where there's only 30% white, and then you would only map that, and then I think that when you start to overlay that data, if you give it, instead of saying, and then within that, you might even decide like you're not saying I'm going to map from 0 to 30, but I'm still going to map like 30 to 40, 40 to 50 as a different category. You might actually just have like one hatch that says this is the population density, these are the areas that have the population densities that I actually care about, instead of saying this is the actual population density for each of these shapefiles. I don't know if that makes any sense.
Mm-hmm. That makes sense.
How do you turn this?